All right, welcome to The Explainer. Today, we're going to pull back the curtain on something that's totally invisible but powers, well, pretty much everything you do online. It's the secret sauce, the real magic behind the tech we use every day. So let's just jump right in. Think about it. How in the world can Google search billions with a B of pages in half a second? Or how does Spotify just know what song to play next instantly? Have you ever stopped to wonder how these apps pull off these crazy fast feats? Well, spoiler alert, it's not actually magic. It's a brilliant, brilliant system of organization. We're talking about data structures and algorithms, or DSA for short. You can think of it as the digital blueprint for any piece of software that needs to be fast and efficient.
So these two things, they're like a dynamic duo. Data structures, those are the filing cabinets. They're all the different ways you can organize and store your information. And algorithms, well, they're the super smart librarians. They're the recipes, the step-by-step instructions that know exactly which filing cabinet to use and how to find what you need, like right now.
In how you organize your data, oh man, it has this massive, almost unbelievable impact on performance. Choosing the right filing cabinet and the right librarian is literally the difference between code that feels lightning fast and code that just doesn't work. We're talking the difference between instant and impossible. Okay, let's put you in the driver's seat. Imagine you're a program. Your one job is to find a single, specific needle in a haystack of 1 billion other needles. A billion entries. Where do you even start? And this chart just lays it all out perfectly. If you take the dumb approach, right, just checking one by one, that could take you a billion operations. A billion. But if you use a smart data structure, something like a binary search tree, the algorithm can find it in about 30 operations. That's not just better, that is a whole different universe of performance. It's a total game changer. That is the power of smart organization. And here's the cool part. This isn't just some abstract computer science theory. This is happening right now, on your phone, inside the apps you use every single day. Take your Spotify playlist, for example. You ever think about how you can just skip songs, go forwards, go backwards so effortlessly? Or how you can just drop a new song right in the middle of a playlist without everything breaking? Well, that's a clever little thing called a linked list. Basically, each song is like a link in a chain, and it knows exactly which song comes before it and which one comes after it. So when you add or remove a song, you're not shuffling the entire deck. Nope. You just have to tell its neighbors, hey, here's the new guy. Super, super fast. Okay, here's another one you use all the time, your browser's back button. It seems so simple, right? But how does it remember the exact sequence of pages you just visited? That is a wonderfully simple and elegant data structure called a stack. Seriously, just picture a stack of plates. The last plate you put on top is the first one you're going to take off. Same idea here. Every new web page you visit gets placed on top of the stack. You hit back, the browser just pops that top page right off, and boom, you're at the one before it. Last in, first out. And all right, let's look at something even more complex. Google Maps. How does it calculate the fastest route through a massive city with thousands of streets, intersections, and traffic jams, and do it all in just a few seconds? That, my friends, is where the graph comes in. It's the ultimate data structure for modeling networks. Think of it like this. Every intersection is a dot, or a node, and every road is a line, or an edge, that connects those dots. Some roads might have a weight, like heavy traffic. Then these incredibly powerful algorithms like A-star or Dijkstra's basically explore this giant web to find the most efficient path from A to B. And honestly, the list just goes on and on. It's all about picking the right tool for the right job. You've got hash tables, making things like Google Translate feel instant. You've got trees organizing all the files on your computer in that neat folder structure. You've got queues making sure your printer handles jobs one at a time, first come, first served. And you've got heaps helping a cloud server figure out which high-priority task it needs to tackle next. It's everywhere. Okay, so we've seen how this stuff works today. But what's really fascinating is that the history of data structures and algorithms is, well, it's pretty much the history of computing itself. It's this continuous story of evolving to solve bigger and bigger problems. It started way back with the theoretical foundations from pioneers like Alan Turing in the 40s. Then you had legends like Donald Knuth, who literally wrote the book on it in the 60s, formalizing the whole field. But then, the internet happened, and everything exploded. The sheer scale of the web demanded totally new ways of thinking, which gave us things like Google's PageRank. And now, Now, DSA is the absolute engine driving AI and big data. And that's why this isn't just some boring stuff you learn in a textbook. No way. This is the bedrock of modern problem solving. It's what separates a good programmer from a truly great one. It's what makes real, groundbreaking innovation even possible. And the impact? It's measured in billions, with a B. Choosing the right data structure saves companies billions of dollars in computing costs every year. It's what makes software faster for you and me, and way cheaper and more scalable for the people building it.
So if there's one thing to take away from all this, it's this. Behind every single tap, every search, every time you think, wow, that was fast, there is a perfectly chosen data structure and a super efficient algorithm doing the heavy lifting. It is the silent, organized, and absolutely essential engine that drives our digital world. And that kind of leaves us with a final question to chew on, right? The amount of data in the world is just growing exponentially. The challenges are only getting bigger and more complex. So what's next? What new filing systems and genius librarians will we need to invent to organize the future? Something to think about.